Hello. Hello, everybody. So, my name is Massimo Nuvoli. I'm from Italy. And the topics of the today's presentation was switching of Mikrotik devices. I think every one of us that has Mikrotik device is using switch. But during the training of my life, I see that never one know how much is powerful the switching of the Mikrotik device. Before that, there is a thank you page for some people, my son, my wife, and some friend of Italy. Then, I am owner of my company, Progetto Archivio. I'm a system engineer. I'm a Linux system engineer. And this is my job, network and system design with performance goal. So, let's go. When I start to think about a talk for mom, I'm not trainer, so it's what's easy for me to do this kind of job because I don't think so much how to tell to the people. But now I become trainer here in Ljubljana, so I want to do the best for us. So, you don't know, I'm sure that you don't know about switching in Mikrotik device, I'm sure. And where is and what you can do with the switch. Some question, please raise your hand. This is quite simple. If you use VLAN, how much VLAN is possible to make on one single L2 connection in the standard way, not strange things. What is the first question? The first 4094 or raise your hand. Okay. Or the second, I can pronounce this one is 4094 multiplied for 4094. Okay. The right answer is the second one, because the standard provides two places to put VLAN ID on a frame. So you can have a combination of two, like I write this, 4094 networks addresses. The second question is basically a problem of knowledge about switching and bridging. The bridge speed and the switch speed are the same. Yes? No? Okay, that's right. The speed of the bridge is the speed of the CPU. There is a fast path. There is all things that you can do, but the speed of the CPU is not as the speed of the switch. And the third question, there is another question that I made. Now, there is not on the presentation. I asked, you are using VLAN in your device usually or not? Raise your hand. Yes? Who tell no? Someone. In the fact, when you use Mikrotik device that have switch inside, every time, without configuring nothing, you are using VLAN. So everyone use VLAN without know of this. Then, this is practical. This is a big problem for the network specialists because we need to change configuration about switches, and it's very normal to do some mistakes. Then you need the serial port to enter in the switch and change configuration. Something goes wrong, so you need to change this and put the switch okay. Then if the device has serial port, is okay, but the device must don't have the serial port. So you can use, and this is what I do here, a USB Ethernet device connected to the router OS system. So you have one added interface that doesn't go to the switch, so it's working. You have this. If you lose the device because error in configuration, you don't lose the configuration of the switch, because you must reset if you don't have this. Okay? Some question? No. Some switching theory. I cut this one because it's very long, but I need to tell you something about. This is not the right definition about the switching, but it's quite right. Switch is a simple device that connects at least two network physical links, L1, and works at level 2. Stop. With VLAN and Q-in-Q, that is the second VLAN inside the frame, you must think that each VLAN is hitting you 4 bytes of packet frame. So if you need to add more VLAN tagging, each time you lose 4 bytes. This is very important because there is a lot of devices, the small devices, that have limitation on the MTU frame size on the physical link. So these 4 bytes are important. And as I told you before, you use every time a switch with VLAN, so you lose every time 4 bytes on physical LAN. Then, what is missing in a switch that produce Mikrotik? The spanning tree. You know what this is, spanning tree protocol? Okay, this is very important because if you are a technician, this is not a problem. If you are in a non-secure environment, it's possible to make a loop in the network. And the spanning tree protocol can break this loop and make all things in the network working. And the other important thing that is important, less than the spanning tree, but is important, is dynamic trunking. We have static trunking on the CRS devices, but we don't have LACP trunking. Hey, we need them. So this is the concept of the switch inside the Mikrotik device, the smallest one, also the big one. There is a switch that can do N ports switching, and one port is connected to the CPU. The other port are for the physical interfaces. It's very important, this. I love that. If you want to buy a Mikrotik device and you want to do switching, you must check block diagram of the device. Please, this twice, not once. Because each device, like this, have a configuration, have a number of ports, and you see that the switch chip have 1 gigabit port to the CPU. One only. And this is a speed limit. This is CRS125 device. It's more complex. This is full wire speed device, so it's very powerful, but there is only 1 gigabit port to the CPU. So this is a problem if you need performance. See also, this is 26 port device, that one port is for the CPU and one port is for the SFP1. And finally, but not less important, CCR device. There is only one CCR device that have switch. The 1000, I think, 9, okay? Is the only one that I remember. The CCR device, all interfaces are directly connected to the core, to the CPU. So we don't have switch. We can do only bridging in this kind of device. So when you have a switch inside a Mikrotik device, because they can also don't have a switch, your ports can be switched by putting them in a group. So you have many slave devices that go with one master port. There is nothing else to do. The router OS is doing all the things that you need. So when you do that, you can see the physical interface on the router OS side, but all the traffic goes to the master port. The other ports are not usable for routing or other things. This is very important. It's the most frequent fault in configuration of not qualified people. So in a small devices, you can define only one switch group. Bigger device, CRS125, can do a lot of them. But if you mix configuration with VLAN and a number plus one, so 2, 3, 4, 6 switch group, this is right, it works. But even in the documentation, if you read the wiki, there is that it's not good. Because we are mixing some configuration between VLAN and switching. After all the presentation, there is one explain about this problem. So, small devices and simple devices can have no switch. More mixed devices. There is a lot of devices like 2011 and 3011 that have two switches, so two capability of be master switch ports. Then they can't be mixed between. So it's very important to check device before buy, because it's not, you are not sure to have a switch, and you are not sure to have the right switch that you need. Check before buy, very important. So what you can do with VLAN management in Mikrotik devices and switch? You have three possibilities. You can do from the core, inside the router or system, in the core in the switch only. This is not obvious, but it's very important. Then, this is my recommendation. You need the scheme of the network. You must do very clear design of your application, your need about VLAN, interconnection, and performance is very important. Then we go to make a little step inside a CRS125 device. I do that with a live device. You can see it's okay. This is the switch menu of configuration of CRS device. There is a lot of options, ACL, the table of MAC address acquired by the switch. And you can see this menu, all option of this menu is doing, all the work that is done by this menu is by hardware device. There is no CPU involved in this operation. So when you do VLAN tagging, or you do more powerful QoS management, shaping, or other things, is the switch chip that is doing that, not the CPU. It's the same also for the other. You can see that. This is 433GL device that have a switch, and is less complex. There is less option, but there is something. And you have the switch chip with characteristics, but this is not important. And you have also, this is very important, port definition and host table, like the FDBD that you see before, VLAN, and rules. These rules, as I said before, are managed by hardware. So if you put a role inside this configuration, you don't touch the CPU. This not seem as powerful, but if you think about this, sorry, Matt. Okay, this one, switch, QoS, and shaping. This is shaping configuration for another port. I say, okay, you can go to 10 megabit. This is done by hardware. There is no CPU involved. So you can choose to regulate the speed of single port interface without touching the CPU. This is powerful. It's not easy, but it is powerful. And you have to make configuration about this kind of shaping. You have two rules, and this is a practical example of what you can do in the switch. You have sometimes only one thing to do, but normally two. You have ingress policy and egress policy. And this is the way you do the shaping. You have one shaping for the output. This is the one. And you have ingress port policies that do the same thing in the in. So you have the choice to make speed for the in and for the out separately. All done by hardware. Very important. Then, I go forward with the presentation. So, you understand, you see that CRS125 is a very complex device. If you want to use this kind of device in the best way, you must read documentation. It's the only thing that you can do, and you must, if you want to do something nasty, you must buy this device, put in the lab, and test. Because it's very powerful, but it's very difficult to configure. As I can say, this is important because it's the topic of the presentation. Interfaces. Oh, lost some window. Sorry. There is too much window open. This is one. Okay. This is the way I like to configure the name of interfaces when you use switching. There is a master port and a slave port. There is a CRS device. So we have 2 and 3 master ports. That's okay. As I told before, this is the simplest configuration. You don't have to use VLAN to do separately switching between this group of ports. It's like you are doing VLAN, but you don't need to do that. You do master, and all traffic is physically separated between each group of interfaces. So if you need to do a VMware implementation, that's what I'm reading then. The only thing that you can do is make more port group for data and the storage, and use full wire speed of the device. You can do with CRS125 12 gigabit of traffic while the device, without touching the CPU, and it's very fast and very powerful. The only limitation about this kind of device that is quite cheap, is not costly, is the MTU size that is small, is 4,000. Okay? Please, read documentation. This is a big problem. If you make a cluster with VMware servers and you put 9,000, that is normally the big MTU size of Jumbo frame, this switch can't handle it. The maximum is 4,000. And the other important thing is that if you assign IP address of the storage and of the running data, of the management data of the VMware system, there is some possibility that VMware tell you, oh, there is a storage, and try to go to the CPU to communicate to the storage. So, so it is very important to have a simple, if you use IP address, simple firewall rule that stop all communication between the storage and VMware on the CRS side, because the CPU can't handle not more than 200 megabit of traffic, non 1 gigabit. So you kill the CPU, okay? This is the wrong schema. Someone can tell me why this is not right. There is only one reason. Because this is real implementation. We have a lot of cable inside the infrastructure, but the problem is the connection with the LAN. As we don't have the spanning tree protocol in a normal environment, you must do that. You must use a managed switch with spanning tree capability. So outside your server farm, you can avoid to have a loop inside your network. This is a way to preserve your life. And I put only comments about this, but it's just to explain the complexity of the configuration of the trunking in a CRS device that is 0. And the same thing that is possible to do in the normal device that have a normal switch that can't do trunking in hardware. So you must do this with bonding, and you must do with this command. It's very complex. On the CRS side, it's like this. You go to the switch, ports, trunk, add, interface. Okay, add a lot of interface, and it's okay. Quite fast, quite simple. This is a very important thing. This is static trunking. We don't have LACP. Okay? So then this is what we look inside the switch before, the speed limit, the 2 rules for the ingress and the output. Then this is behind the switch. As at the start, I ask you if someone is using VLAN, but usually you buy a device that have 5 ports, and this is switched in 1 port inside the CPU, but when you go to the router host configuration, you see each single port. What is possible? This is the only explain about this. You have each port assigned to a VLAN. A, B, C, D, A is only number of VLAN that is starting from 4094 and going down. So you have also a limit inside the router host of number of VLAN because they are using VLAN to do this kind of job. We can say that. And the port 0 is assigned VLAN 0, then go inside the Ethernet CPU with all VLAN together, then the traffic is separated in each port, Ethernet 0, 1 is configured to be in the correct VLAN. When you do, and before I said precisely this kind, when you do a group, you define only the slave, not the master, because the master remain unchanged. You go to the slave interface and tell to the slave interface, you are slave of, and you assign to the physical port the VLAN of the Ethernet port correspondingly inside the switch. So this is why you can see no more traffic on the VLAN B that I have in fact disabled, and 2 ports, VLAN A, going to the Ethernet 0 VLAN A. It's quite complex, but you can understand that this is the way. And if you look inside documentation of some device, you can see that the packet size of the MTU device Ethernet 0 is 1,526, but on the switched port, the same packet is 22. So we are hitting 4 bytes to do this. Okay? And there is some question? Something to ask? Yes?
Hello. I have one addition. You had one of the slides stating that slave interfaces, you can't see traffic on them. This is actually one of the requests of most of the technicians to see the traffic on the slave interface, and you can do that both in CRS and on normal router boards by mirroring the traffic on the slave interface towards the CPU, and then you can torch the interface. So this is my addition for the audience. And my question is, you showed on the CRS that you can add rules which limit bandwidth and do different stuff based on egress and ingress. Have you tested that, and does that affect capacity of the switch in production?
Yes, I made some tests about this kind of configuration. The problem of the capability of the switch chip inside the CRS device is not the speed. The problem is the limit on the number of queue and interface and rule that you can put in. So this is hardware device, it's not in software. So you have 32 rules. You have a number of, is very difficult. If you need a lot of rules, you can do that. There is a limit. And more complex switch can do more rules or more configuration, but this is device dependent. But I think in the speed area, I know that CRS125 is very powerful. It doesn't affect the communication between other ports too. It's very important, very powerful.
Thank you. Any more questions? No? Okay. Thank you, Massimo.
Thank you.
Now we're going for the lunch.